Good afternoon, ladies and gentlemen. One last time, welcome back to the final session in our program. Timber is an increasingly popular building material, not only for the comfort it provides, but also as a possible means of balancing out the ecological footprint of the construction industry. Let's hear which new possibilities and opportunities are opened up by the Second Generation Eurocode 5. Mr. Winter, please.
Thank you very much. Ladies and gentlemen, let's rock the afternoon. Last session, but the most interesting one, of course. We are leaving artificial materials and design based on artificial materials. We are coming to nature-based materials. Timber, coming from the forests. Geotechnical engineering, dealing with soil and ground, mainly also based on nature. And Mother Earth. Most of the cases, Mother Earth is friendly to us. We are not to her. That's a problem. Probably that's why she is sometimes nasty to us and answering with earthquakes. So earthquake design, the last presentation this afternoon. Let's start with timber. Design of timber structures EN 1995-1-1 and all the other parts was created by more than 200 subcommittee members and many other experts based on the national standardization bodies and in the mirror committees. So from this point, and I hope some of you are following us at the moment, many thanks to all of you helping us to create this set of Eurocode 5 standards in the second generation. I would like to stay a little bit with this slide to explain what sometimes the main difficulties in the timber sector we had. We have in total nowadays 11 working groups. We started with 10 working groups, and going through the working groups, I can explain a little bit the composition of the Eurocode 5 family. In working group 1, cross-laminated timber, we dealt with a new material on the market, which was not available in the first generation of the Eurocodes, but nowadays is produced with an amount of about 1.3 million cubic per year in mid-Europe only. So new material, new design rules. The content is going to part 1.1. Timber concrete composite, also nearly not available for the first generation. This is a closed job because the working group 2 and the relevant project team, they delivered EN CEN TS 19103. So PREN 1995-1-3. This is a new part of the Eurocode. Closed job dealt with in working group 2. Working group 3, cluster Eurocode 5. Well, all these things only under a little revision, sometimes a major revision, a sampling basket, huge workload, of course, going to part 1.1. Structural fire design, going to part 1995-1-2, is again a closed job. They produced the fire part of the Eurocode together with the project team. Working group 5, connections and fasteners. Again, a lot of new technology. Going to part 1.1. Timber bridges, closed job, part 2. We kept our part 2 for bridges and opposite to the concrete design, for example. Reinforcement, going to part 1.1. Seismic design, a parallel group with Eurocode 8 under the convenership of Philipp Bisch, is a connecting group working in both subcommittees. Execution is again a closed job. Compared to other sectors, we don't have a technical committee in the timber sector which is able and willing to deal with execution rules. That's why we asked TC 250 that if we are able in SC5 to do that. After a lengthy discussion, finally we did it, and it's a little bit comparable to EN 1090, for example, from the steel sector, but you have a separate technical committee dealing with 1090. Basis of design and materials is, again, a major part of 1.1. And this is a totally new working group. This will not appear in the actual publications of the Eurocodes. You see convener pending, professional standardization support pending. It's a new group inspired, Ulrike, from the steel sector to have a setup of calculation rules also for finite element-based design in future, though this probably ends up in a technical report or a technical specification in some years, but not in the actual publication range. In addition, we need, therefore, a task group sampling all together these things in one part 1.1. Of course, we discussed sometimes, well, should we do it a little bit like the steel sector, separate it more, have more different parts. At the final, for connections, for example, there could be a solution. But at the final end, we decided, no, let's leave it together. It's a question of ease of use, but you can have, of course, different viewpoints. In addition, we have now 2 ad hoc groups, background documents, where we sample at the moment the technical background documents from the project teams and from the working groups. And we would like to produce, and this is related to the question we had in the morning, background documents, is this also a part of ease of use? And the answer is yes. We had in the past STEP edition, which is Structural Timber Education Program, and we want to produce also a new set of books with explanations, examples for the practice. And personally, I hope that we are able probably to shift also some content we have at the moment in part 1.1 only also to this sector in future. And finally, we have an ad hoc group about existing timber structures. You heard about that in the report of Nick about 1991. Existing structures, and at the same time we have working group 2 under the convenership of Mr. Lang, for example, dealing with the existing structures, and we are supporting this, of course. As a summary, in total the Eurocode 5 family has 5 parts. The new ones are part 3, timber concrete composite structures, currently as TS 19103 available, will be transferred now to 1995-1-3. We have the part 2 bridges and a new part 3 execution, and the general rules and rules for building, the fire design and the bridges, they were revised. What are the targets? Of course, a harmonization with the whole Eurocode family. Timber concrete composites should be harmonized with Eurocode 2 and with Eurocode 4, for example, in some aspects. And of course, we have to mirror the tremendous development of timber structures in the past 30 years. It's related to the size of the buildings. We nowadays create high-rise timber buildings with a height of 100 meters, actual build. The size, the total size of timber buildings is rising. A lot of multi-story flats, for example, flat buildings are built in timber nowadays. And therefore, we need an extension and a revision of several rules for timber design. In addition, we want to improve the interface between EN 1995 and product standards. This is of major importance for us. I will come back to this a little bit later. Of course, same targets as everywhere, reduction of national determined parameters and of alternative design methods, and finally, outsourcing of very specific design rules from the main text body to normative annexes to make it easier to navigate, also a part of ease of use, of course. And you mentioned it at the beginning. Well, timber has a real hype at the moment, based a little bit of his ability of its ability to store carbon and therefore to provide a carbon sink if you use it as a long-lasting material, as a long-lasting structure. And of course, if you do a Eurocode design, that will be a long-lasting structure because it's reliable. All you see is wood. This is an example for a typical housing area nowadays. In this case, it's in Munich, where all of these buildings are out of timber. Even sometimes you may not recognize it from the outside. So coming to part 1.1. And one of the specialities of timber structures, we have a lot of construction products. In former times, when we started with the first generation, we had structural timber, solid timber, and we had glulam. Full stop, more or less. Of course, some particle board and some plywood. OSB, now the main wood-based panel, not available during that time. Laminated veneer lumber, available but not used as a structural material. Nowadays used as structural material in a big amount, and not only in softwood, only in hardwood, beech, for example. Plywood, gypsum fiber boards, gypsum plaster boards, also used as structural paneling, for example. I chose, etc., etc., etc. So we have really a high amount of construction products to deal with and to find design rules for them. Compared to steel or to concrete, a little bit more complicated. In addition, an enormous development in the connection sector. We have not only smooth nails or ring shank nails, we have a high number of different types of screws nowadays, fully threaded, not fully threaded, etc. Of course, we have dowels and bolts. That's what we had also in the past. But it's a high variation of connections and connectors and nails and screws, etc., available on the market, and we need design rules for it. In addition, and that's nice, we have a revival of carpenter joints. Why? Because especially in the timber sector, we have a really high amount of CAD, CAM-based manufacturing. And based on CAD and roboting, we are able to produce very precise structures, and therefore we are nowadays again able to use these connections, which are not any longer handmade, they are produced. This all leads to really a high amount of new content, and that's why I'm unfortunately not able to go through all the things today with you in detail as some of our colleagues did. It's too much. So I would like to stick to the principles and some examples of the new contents. For example, reinforcement is a very important new content. You know, in concrete design, you always do reinforcement because the tension capacity of the pure concrete is not so high. It's unfortunately a little bit the same with timber structures, especially perpendicular to the grain, where we have zero strength. So we need reinforcements. That was not mirrored in the last generation. Nowadays it is. And you need, of course, especially then, reinforcement if you have notches or holes in beams which create additional tension perpendicular to grain. As you have seen before, we have an increase in the size of buildings, in the height of the buildings, and therefore, of course, you are ending up in more complicated structures to take lateral loads. And you need a combination. You have CLT walls in combination with timber framed walls, in combination sometimes or very often with concrete shafts and staircases out of concrete. And you have to combine that, and you need some rules for it, of course. That's what we tried to integrate. We outsourced also something, especially to normative annexes. For example, foundations with timber piles. That was a special request, not from Germany. but from our friends from the Netherlands, for example, or from Italy, because they have foundations like that in their cities sometimes up to now. And for example, nail plate structures, these design rules are mainly used by software companies writing the design programs or specialists dealing with these structures. So we moved it out from the main text body and put it, of course, in a normative annex, because, as you know, the Eurocodes are implemented finally in the different countries. And you mentioned it, Steve, it's a different process. But if the annex is normative, then normally it's also valid under the application of the building regulations. Let's leave part 1.1, so the normal temperature design, and come to fire design. And again, we have, as an example, cross-laminated timber. Cross-laminated timber, I said it before, a mass timber product nowadays is built up of crosswise layers of buttons. And that's why the charring behavior is a little bit another one compared to solid timber or to glulam. That's what we have to take into account, for example, in fire design. So we had an extension of design rules, mainly for the effective cross-section method. And we try to apply it now for I-joists, cross-laminated timber, and timber concrete composite elements. We skipped the reduced strength and stiffness method, so that's totally out. We are only relying to the effective cross-section method, and one of the reasons is that the reduced strength and stiffness method was not used really. So we agreed that we should skip it. We have a design model for the verification of the separating function of wall and floor assemblies improved. This was also in the first generation implemented, but only for a time span of 60 minutes of fire resistance. This is now increased for 90 minutes fire resistance. Again, a result that we are built now high-rise buildings, and then they require, of course, higher fire resistances. And also the failure time, the falling off of fire protection systems, the design methods for this are improved. The T-char, so the protection time or the time until the timber starts charring is now based on better calculation methods. We had a number of revisions of design rules. Charring, for example, we have this step model, famous one, especially valid for cross-laminated timber because layers are falling down, and then you have a preheating of the next layer, and then the charring is increased for a certain time span, and then it's going back to the normal charring rate. This is now integrated. We have an update of timber frame assemblies. Connections and fires also have now design rules for 90 minutes fire resistance, which was limited before only to 60 minutes. And of course, detailing for the case of fire was improved, and also the design of timber structures exposed to physically based design fires. And this connects us now again to what Nick mentioned in the morning. Annex H in 1991-1-2 are giving the fire loads, and Annex A in 1995-1-2 is providing the design rules under national fire exposure. Timber concrete composite structures. Well, as mentioned before, this is a high increase. We use it mainly for wide span floors, sometimes also for walls, but mainly for wide span floors in offices, in kindergarten, in schools, etc. And of course also in multi-story dwellings. Especially, they provide also a very good fire protection because you are producing always a complete non-combustible layer, and then the next layer of timber is following again. Sometimes built on site. These are pictures, quite old pictures from Berlin, from Esmarkstraße in northeast of Berlin, where one of the first multi-story buildings in timber here in Berlin was built. So sometimes on-site, very often nowadays also delivered as a construction product, prefabricated in a factory, and then coming to the building site, the whole element. And with the typical technology of concrete, then the gaps are closed by screed, and that's it. We have already a pilot stage based on TS 19103. We give there the load carrying capacity and the slip modulus of the connections with dowel type fasteners, bonded in rods or notch connections. There is a modification of creep coefficients for composite action and slab systems and in beam systems, and we have also a calculation method for the effect of inelastic strains and some other hinds for detailing. Personal hind, you have to use the correct concrete, not the cheapest one you have available. So, of course, you need also a very good concrete design so that you have low creep, for example, and therefore low deformation. And if you build this, it's not only necessary to have knowledge in timber structures, you also need a good knowledge in concrete structures, of course. Bridges. Well, we have some very old timber bridges in the foreground. You see a more than 150-year-old railway bridge in Kempton, which was a repair situation here. But we have a lot of modern bridges as well, out of timber, especially in the alpine area, but also more and more in other areas. We extended the design rules for durability and detailing because moisture is a bigger enemy than fire, to be honest, for timber structures. And that's why you have a lot of detailing now also in the Eurocode to provide dry timber structure for a long lifespan. We have new design rules for deck plates and also first time for integral bridges. And we revised the design rules in the bridge part for timber concrete composite, of course, in relationship to 19103. We integrated laminated veneer lumber, vibrations and damping, and also some additional fatigue rules. By the way, for fatigue, we have now also a chapter in part 1.1, because if you think about the high-rise buildings, they also have sometimes fatigue design situations, of course. Execution. Not available before. Now, well, we had some very small part of execution rules in part 10 of part 1.1, and we agreed at the beginning of the work in TC 250 that we will put out all the execution rules from the main parts of the Eurocodes. That's why here now 1995-3 execution, where you will find rules for the tolerances in connections, for the tolerances for member dimensions, the tolerances of erected members and moisture control. Finally, that's the same with the material. We have to ensure on the building side that what is designed is built and that the design fits to what is built finally. And therefore, we give, of course, the rules in the execution standard. So, coming to the end, again, a conclusion. You see 5 different parts in future, 2 new ones, 3 revised ones. And I would like to end a little bit with a hint to a discussion which is, I think, always ongoing. And that's a discussion of number of pages. Is ease of use related to a reduction of number of pages? Question mark. I think the answer is definitely no. What you have seen, we have a really enormous development seen in the last 20, 30 years in timber structures, based on a lot of research, based on a lot of additional practice. What we want to do is describe state of art. And if the state of art developed in such a way, you need a little bit more pages to describe it. I have no other idea. And that's nothing to do with ease of use. Of course, in addition, we agreed that the first 10 chapters of all Eurocodes have the same numbering and the name heading, and the same heading. This is also part of ease of use. Yeah? Those who are not doing steel design on a daily practice, they know they find the information in the same chapter in Eurocode 3 as well in Eurocode 4, 5, 6, etc. The numbering is changing. That's also valid for all Eurocodes, I think, because we integrated terms and definitions as an extra chapter. Fatigue is also the same in all Eurocodes now in the part 1 ones. And then the 11 to 14, these are the special ones. Well, at the final end, you see that the main part is 244 pages. That is a small increase compared to the first generation, but the total number is more than 400 pages. In the last generation, we had 250, something like that. Well, in addition, I would like to mention the Annex M, which is related to all the materials. And in this Annex M, we give the strength and stiffness properties we need for design as an information for the designer and for the European Commission, that they know what they should implement in the standardization requests or what they should implement in their papers in the request for the builders, what they have to deliver. And if you have such a lot of materials, you may imagine that Annex M alone is about 80 pages or something like that. Okay, this is one of the reasons. So, in total, I think that all the Eurocodes, to be honest, are very important to deliver a grandchildren-fitting built environment in the future with increased resource efficiency. And of course, I'm convinced that timber structures are able to provide a special part to it. Thank you very much for your attention. And hopefully I'm on time.
Yes, perfectly.
Yes, I am.
Thank you, Mr. Winter, for this illustration of how innovations in the timber industry have driven and are driving Eurocode writing. We will see you back in 50 minutes for the question and answer panel. So this is also your cue to start sending in your questions. And we go on with our next speaker. The Bible advises us not to build a house on sand. Adrian von Setes now has the state of the art according to the upcoming Eurocode 7.
I would suggest to do it. I mean, build it on sand. It's better than on soft clay. Welcome. Thanks for the invitation to speak here and for this marvelous congress. I would like to address the Eurocode 7. Eurocode 7 has 3 parts. Part 1 is on general rules, 2 is dealing with ground properties, and part 3 is dealing with geotechnical structures. But before I go into that, I must say that Eurocode 7 is a bit different. Because we have many soils or rocks in the EU, so it's not like concrete or steel or even like timber, very uniform, but that also leads to many different traditions. Also, the way you connoitre the soils, how you get your samples and what you do with it, and how you derive your parameters is completely different in the countries, and also the ways to compute your safety, so the different calculation models. And therefore, we concentrate on safety. We have a lot of calculation models, but they're in informative annexes. At the moment, all 3 parts are in the drafting phase for formal vote, and at least the first 2 parts will have a formal vote in April, May next year. Part 3 probably comes a half year later. The main changes in Eurocode 7. In the old days, we had 3 books on our desks, which was EN 1990, Basis of Geotechnical, of Structural Design, I must say. Part 1, dealing with the general rules and also with geotechnical structures. And Part 2, dealing with ground investigation and testing. And in the new Eurocode, I think Paolo already mentioned it, we have on our computer, of course, 4 parts, where the first one is basic of design, and it's structural and geotechnical design, as Paolo already said. Then there's a general rule, part 1, ground properties, which is a different focus on how you derive your properties and directly added for the designer, and a part on geotechnical structures with many calculation models in the annex. So there's 4 different parts. And then, of course, what is it? It delivers you a toolbox, as given here, for the designer. And in that toolbox are the 4 parts. But what you want with it is to get your structure in ULS safe. In SLS, your deformation should not be big enough, because it's very important for the geotechnical engineer. But also, it should be durable, robust, and sustainable. And also these aspects, well, the others have already introduced that, but it's also in Eurocode 7. So actually, it's not a 2D thing, but it's a 3D, and it is a cube. And so we should take care with Eurocode 7 that our structure is inside the cube. Part 1, general rules. Key changes. We had in the old version a geotechnical category, and it was not completely clear what it was, but the difference is for structural items, you have a consequence clause, which is dealing with the function and of the structure. Whereas here, we have a second component, because there is the soil. You can't choose it. It's there, and you have to look at the risks. Representative value determination. We have soil is very different in parameters, and if you do tests, the range of the parameters can be widely spread. So there we adjusted a way to get to representative values by integer adjustment or by statistics. And we must also be prepared that in the future we talk about huge databases of test results, and we have to deal with it. Groundwater, the hidden killer of lots of structures. It's an important issue also here in Eurocode 7 Part 1. And then safety numerical methods. It was already mentioned in other Eurocodes, but I think for geotechnical, we do a lot of continuum mechanics, and there we need extra rules. So the first one, geotechnical categories. We made a concept of a consequence class, which is described in Eurocode in 1990, and in the geotechnical complexity class. And the geotechnical complexity class is a function of the ground. If you have a difficult ground, a quick clay, or a very soft one, or whatever, you end up in a different complexity class. And the two you combine, as you can see in this matrix. Here's your consequence class, this is your complexity class. Lower, the simple ground, say sand, and higher a peat or shifted rock or something. Combining them, you have a geotechnical category 1, 2, and 3. And those three things determine whether you have to do lots of ground investigation, or how do you have to validate your calculation models, your monitoring, and it's also connected with EN 1990 with design check levels and inspection levels and so on. So in this case we have increased the this phenomenon of geotechnical category compared to the previous one. Representative values, you always have to look for a value which is safe enough, and in geotechnics you often have not many test data. So what we had in the previous code is a definition of a characteristic value or representative. It is a cautious estimate of the values. We still have that because in some cases you don't have much data, but if you have data, you can do statistics. So there's an annex with statistics on it, and it leads you to a characteristic value. And those two, characteristic values or nominal values, those give you the representative ones, which you need at the beginning of your calculation. Safety. Already, this is a table Paolo showed in EN 1990. I'm glad it was adjusted, I think, for geotechnical engineers, but I'm not sure. But this is the table we use for foundations. Here you see the permanent actions. We have a verification case 1 with load factors and load factors on variable actions. So that's normally done, and if you have a pile, then you use this because you get a resistance at the other end. But for a slope, it's different, because the permanent action of the slope itself, it's the mass of the material, and that mass works as a load, but it also works as a resistance, because how bigger the mass, the bigger the resistance. So luckily there is a VC3 where the factor on permanent action is 1 and on variable action is 1.3. Sometimes there is also, when we analyzing retaining walls, there's a problem where you don't know exactly where to put the safety factors. And then we have a new verification case, verification 4, case 4, and that works by analyzing it with characteristic values or representative values, and then at the end add a safety factor, and that's shown here. So all the permanent actions are not valued. The variable action is valued by 1.1, which is the difference between the 1.5 of variable and the 1.35 of permanent. And then at the end you have a result, an effect of actions, and you factor it by 1.35. So that helps us in geotechnics very much to analyze our structures. Material factors. We have 2 sets of material factors in Eurocode 7. One set is all 1, that goes with the VC4, which I just discussed, and the other one set has material factors, and it goes with VC3, where you have no permanent load, but you use material factors to make the difference. And of course, there is an adjustment for CC classes, as in the also in EN 1990. Groundwater. As I said, is very important for us. It's important to have the right value of your groundwater level. And what you normally get is, What you normally have is some kind of some readings, and you don't know what should I take. Should I take the upper one or the lower one or something in between? We have written a chapter on this, how to derive the representative values of a groundwater pressure. And you can do it by two ways, or you take the high one or the low one, or you take the average one and you take the amplitude. So those are the two possibilities. And then you go for a design value. You can do that directly if there is, for instance, a dike which cannot, which overflows, and you know that's the maximum. Or you can apply an offset, or you apply a partial factor. And of course, there's some statistics can be behind it, and well, that's described. Another point. Important point is how to deal with numerical methods. We had quite some discussions in Eurocode 7 how we would tackle that, because normally we work with analytical values and we know where to put the safety factor. So we ended up with two possibilities. One is dealing with input factoring and output factoring. So you make two calculations. And here, for instance, you have a retaining structure with input factoring. What you do is reduce the strength of the material until failure is there. And the reduction is your safety margin. The other one is output factoring. It's actually a verification case 4. You put all the material factors on one, and you calculate your bending moment in your sheet pile, and you put on the resistance factor on your moment and effective actions to derive at it. Also, you can do it by output factoring only, but then you need an effective action factor from the verification case 4, but also an extra factor on the resistance. So those two options, A and B, are available. Ground properties, Eurocode Part 2. Key changes is that we, in the previous version, we had a description of testing with references to the testing standards, and from that there were some annexes how to derive your properties. What you did here is the designer needs the properties. He's not interested in the test, but he wants the property and how to get it. So we have a property stiffness and how you get it from a triaxial test or from a CPT or from another test, all in the same ballpark. So that's how it was organized. And furthermore, we have 3 other chapters, one on the ground model I will show next, planning and ground investigation methods, a brief description. And here are all the chapter headings with the various properties. The ground model is something new. It is more a concept than a real model. It gives all the information you need when you are going to design a geotechnical structure. So what you do is you need of course the geodetics, how your structure looks like if you have a slope on the left side, but also the results of the boreholes, the CPTs, everything is there. And based on that, you can make a schematization, characterization of your ground. You start rough, but if you have more investigation points, you see here different layers existing, and you get the properties in. So this is something which is developed in the design, and it can be a report, it can be a drawing, it can be a database, but it is a conceptual thing what you need before you do your analysis. Then the derivation of ground properties, as I already said, there are 6 or 7 chapters with parameters. All are similar. We have given in tables how we derive these properties from soil strength test. So this is the peak effective cohesion. What kind of test, where you can find it, and some comments. And also there are correlations for indirect derivation. So if you have a CPT, you measure the cone resistance, and from that you have a formula to get your friction angle. And that's given in all the annexes. So it's very handy. Then we come to part 3. On this time, I think we're dealing there with the geotechnical structures. And we have quite a number of new structures. We have introduced pile groups and pile rafts in clause 6, reinforced fill, soil nails, ground improvement, improving the properties of the ground, groundwater control, and rock bolts, all new. And also we updated, of course, completely the slopes, spread foundations, piles, retaining structures, and the anchors. I will just go briefly through the structures. Slopes, the engineering is quite common, and it's one of the things we all do the same in Europe. So that's great. It's harmonized. It works. We have only one design material factor approach. So we use VC3 with material factors, and that's it. Fantastic. But spread foundations. The good thing is the concrete slabs on the ground, for instance. We have one bearing capacity formula, which we use everywhere, so we put it in the main text. We look at drained, undrained, sliding failure, we look at settlements. But our partial factors are different in the countries. So some countries, they do follow a material factor approach, and they do 2 checks. They do a VC1 with factors on the actions, and have a material factors of 1, together with VC3, where you have no action factors almost, and VCM2. So this is with material factors. You do both combinations. You can also say, I do this one together with that one, and then you end up this green column. Or we have a resistance factor approach. VC1 and VC4 are both allowed. This is tradition. We weren't able to mitigate this, but well, this is the widest. I will not say the worst, but the widest example of the analysis. Pile foundations. We had a pile classification system and partial factors. We ended up to harmonize axial loading for single piles, only resistance factoring. I think that's a great achievement. I think the UK was in the past working with VC2 analyses, but we all now decided to do resistance factoring, so harmonizing. Transverse loading, only material factoring. Okay, and then we have different computation methods. A new topic is pile groups and piled rafts. We do the ULS verification with material factors and resistance factoring. And we have some models for bearing capacity in groups, and also a model for negative shaft friction. Retaining structures. Also there we have the different models. There's analytical models, that's a beam with springs on the next to it, but also continuum models where you have finite element continuum models like Pluxus and so on to analyze it, and both are a common practice nowadays. Some parameters for active passive pressures, different material and resistance factors. Often both checks are necessary. What also is new is we have a section of observational method. The observational method is a way to optimize your structure by looking in the design at different scenarios. And you make different sums with different scenarios, and you say, well, I'm going to monitoring everything, and if my monitoring shows that I have to do something else, so for instance, for a retaining wall, put in an extra strut or an anchor, I can do that, but I don't do that in the beginning. And that way I can optimize my structure, and I also can make it cheaper. So that's described especially for retaining structures. Anchors. Anchors are characterized as anchors with a free length. There's a lot of, for anchors, especially grouted ones, it's very much execution dependent. So all verification is in the end done by testing. Every anchor has to be tested with a proof load. Reinforced fill structures. A new topic where you have these kind of like terre-armée structures, concrete facing with anchors in the fill, or you have a geotextile which is bent back to take the load. Also, this is now in their rules for designing them in Eurocode 7. Soil-nailed structures, similar also to get a very steep slope with nails, with a covering of the face. Again, now dealt with. Another big chapter is on ground improvement, and there we have two different methods: diffused methods, where you completely fill up the new the ground with concrete, or you densify it or improve it. The other thing is a discrete method where you put columns of stone columns of sand, or jet grout columns, those things. Also design rules. And because there's also an overlap with piles. What is a concrete column and what is a pile? So these things are taken into account. Groundwater control, another chapter dealing with drainage, so pumping, getting water out, but also with sealing the ground by grouting. And the last chapter is on rock bolts, to keep the rock surface stable with bolts, and with sprayed concrete, and wire meshes are also included there. So, come to a conclusion. A new Eurocode 7, so it's time for you all to update your toolbox and get your structure inside your cube. And we did a lot to help you there. So, and there's a lot of material. So I all hope you use it and get into the geotechnics of your structure. And then our last sheet, further information on Eurocode 7. At the moment we are giving webinars, and it's organized by NEN, the Dutch the standardization committee, and we have every 3 months there is a webinar. You can join through the NEN website. And also, we are making at the moment with GRC guidelines, and they are for difficult topics, and new ones. So there will be one from derived value to design material properties. So how do we do it with statistics and selecting the properties? The ground model, reliability-based verification, so probabilistic design of geotechnical structures will be addressed there. And also, we talk a lot about monitoring plans and execution plans and things like that, but how does it work in the execution phase? And we have a lot of examples where that is given. And the last, we have made a lot of design examples to check the code. That's where I want to finish my lecture. Thanks very much.
Thank you, Mr. Van Seters, for providing us with a toolbox for geotechnical design. Natural disasters like the earthquake in Turkey and Syria remind us of the importance of seismic design and its consistent implementation. Philipp Bisch will give us an update on the latest Eurocode developments related to earthquake resistance. Thank you.
Thank you. So I'm very glad to be here again in Berlin, and also to listen to my colleagues, and because, as you know, Eurocode 8 complements the other Eurocodes. So we have to know every other Eurocode to be able to develop Eurocode 8. So I've been involved in the development of Eurocode 8 since the beginning of the ENV stage. So it was in the last years of the 80s. So it was last century. Okay. So the interest of that is I could follow the development of Eurocode 8, of course. The physical basis are still the same. Eurocode 8 is based on earthquake engineering. So it is, let's say, a set of knowledge which have been developed, let's say, during 1 century, a little more than 1 century. Okay, so of course this development was progressive. We are taking knowledge from seismology, from mechanics in general, from, of course, structural mechanics. But we are beyond, because you know the effect of an earthquake. So we have to deal with the behavior of structures which have a specific behavior, which is first cyclic, and second, in the plastic range, okay? And of course, we have to take all steps to avoid any failure of the structure, even sometimes locally. So this is really specific, but once again, we only complement the other Eurocodes. So my presentation, there are 3 main sections in my presentations. Okay. I was talking of earthquake engineering. There has been a very important development of earthquake engineering in the past years all over the world, because of course you know the disasters caused by the earthquakes, and I think all countries are very interested in trying to control the behavior of structure during an earthquake. Okay. So you have many research projects all over the world to try to better understand and to develop better models which are in the codes. At this stage, I would say that all the codes in developed countries have a similar, of course, physical basis, but also similar development, even if the environment is different. Of course, the procedures may be different, the ways to verify are different, but there is an overall consensus in the world for the codes. And the final result is it's clear. If you respect the codes and, of course, see if the construction follows the good design, so good design and good construction, then the result is really very good. So It is important to apply the codes all over the world. In Europe, there has been many research programs, many of them financed by the Commission for using all the experimental means that we have. We have equipment in Europe, many equipment, shaking tables, reaction walls, etc. And we have the capacity in the research team to develop new models, etc. This is very important. And all this, the results of this research, of course, should be considered, because 20 years between two generations for Eurocode 8, it's long, because you had a lot of evolutions. This is what I'm going to try to show you. It's the main topics in these evolutions. I will just, to finish this introduction, show one example, which is clear. It's about method of analysis and verification. In the past, the verification were based on a force-based approach. I mean, a linear analysis and verification of stresses and forces according to other Eurocodes. But it is not really physically the best way to do it. Now we have many results. We have the development of many models for representing the behavior of materials in the non-linear range, and don't forget that it is in cyclic situations. So it's different than for other loads, except perhaps some like snow, for wind, for example. Okay, so we have many models, theoretical models, and also we have the development of computers, which means that we are able now to make very refined analysis. And this is very useful for a displacement-based approach, which is fully non-linear. But now in Eurocode 8, you have the two possibilities. Force-based is, of course, simpler, but displacement-based is much more recurrent and also much more efficient. Okay, so it is a choice. It's open to the designer, who can choose whatever he wants. Okay, so first we had to follow, of course, the evolution of the others, as I told you, and we have to try to be consistent. And I will not explain in detail, but we had many exchanges with the others, including it was important with Eurocode 7, because we have a part 5, which is related to geotechnics. So it worked very well. In fact, I hope we are as much as consistent as possible. I will just draw your attention to some choices which have been made in consistency with Eurocode 0, which is, of course, is important. So you have seen this morning that you have the definition of consequence classes now in Eurocode 0. In Eurocode 8, we have importance classes, which is not exactly the same, but if we look at the definition, they were relatively close, okay? But also, within Eurocode 8, it was different in the different parts. So we had 4 importance classes, okay, and we wanted to use the consequences classes that you know, CC1, CC2, CC3. The problem, one of the problems of Eurocode 8 is that it is very often in many countries directly in relation with regulation. So on one side, you have Eurocode 8 and the national annexes, but you also have all the regulatory texts that exist. Of course, this is a constraint, because we cannot only develop what we want, we also have to take the final decisions which will be taken at, let's say, a political level, and mainly, of course, as related to safety. And it happens that in many legal texts, you have a clear definition of these categories. So we could not change, because we cannot change the law, of course. So we can only change Eurocode 8. So what we have done, just to mirror these categories, is to divide, which was authorized by Eurocode 0. We have decided to divide CC3 in 2 to cope with categories 3 and 4, which were here. I insist on this. We are also working in, let's say, a legal environment, and we are not only talking of technical text, we also have to look at what happens after in the different members. And of course, it's not the same if you look at the legislation in southern countries or in northern countries. It's very different, okay? But it has consequences. So another thing, we were using, I will say that the Eurocode 8 family was not completely consistent. If you look at different parts, we had, for the limit states, it was different between, so 1 and 2, 1 is for bridges, buildings, and 2 for bridges, okay? And for new structures, we have others, but mainly those. And part 3 is for assessment. I mentioned here that part 3 was developed since the beginning at the NV stage for the assessment of existing structure in seismic situation. Okay, so this exists. This has been existing for a very long time. Huh? Okay, but we had defined in part 3 these 3 limit states. So this one is the same as this one, even if the name is not the same. Okay, this one is the same, but this one did not exist. Near collapse is really near collapse. Here, no collapse is not near collapse. You have still some margin, of course, for new structure. Okay? So we have decided to use, of course, the definition which are better, those in Eurocode 0. And we have added also another limit state which is operational, the request of some members, because sometimes for certain level of earthquake, you need to have an operation for certain parts of an hospital, for instance. You need to have it so for in the situation of crisis. So we have added that, and then we have all those limit states, but we are clearly referenced at the ultimate and serviceability. Of course, all what was related to safety of people and structure is in ULS. And of course, it is mandatory to verify one ULS, mainly this one. The other are optional. It may depend on the type of structure. It depends on the member, whether they want or not verifying these types of limit states. Okay? So this choice is in the national annex. It may be also in the project. You remember that there was a will from the Commission to reduce the number of national parameters. So you have the comparison at this stage between the first and the second generation. So you can see that there has been a very important effort to decrease this number. But the way to do it is really very important. We have tried to concentrate Eurocode 8 only on the technical issues. And you will see that all the safety choices are left to the member. So it may be in the national annex or in legal text, depending on the member. So you will find only technical solutions, and to help the members to choose their safety level, you have different levels of choices, but which are clear. And this was also an help to reduce the number of NDPs. So we have also realized, now we are internal in Eurocode 8. We have realized that organization was not so consistent. And so in the previous generation, you had the seismic action, of course, definition of seismic action, and the general rules, which were together in part 1. Okay, so general rules and buildings. Then we had bridges and the other structures, okay, and 3. What we have seen is that there were many repetitions, in fact, between, for instance, 2 and the others, and part 1. And sometimes there were even inconsistencies, okay? So to make this new organization was also a way to decrease the number of pages and to avoid the repetition, and of course to have everything consistent between the different parts. So we have decided, of course it has been accepted by TC 250, to divide part 1 into 2 sub-parts. But if you want to have the previous part 1, you take the 2, you glue the them, and you have part 1, okay? The interest we have removed from the other parts, what is dealt with in the general part, okay? So it is a simplification. Of course, it is consistent. And then you have 3 levels. You have the first level, so mainly part 1.1, and also part 5, because we have put in part 5 all what is related to geotechnics, geotechnical structure, foundations, etc., which is common to buildings, bridges, etc. And we have kept in the other parts only what is really specific to the different types of structures. We have put together part 4 and 6 because there were, let's say, relatively light standards, and there were no real sense to have them separated. Okay, and part 3, of course, it's important, except the fact that in part 3 we have added bridges. Okay, what are the fundamental requirements for Eurocode 8? Okay, of course, it is to protect human life, but also to limit the damage, because you have seen the different earthquake at the TV, and you can imagine that the loss is not only, of course, the more important is human life, but not only. You have seen also the economic disaster. So we also have to protect somehow the structures themselves. And of course, we have to take care of civil protection, because when you have an earthquake, of course, you need civil protection, okay? And, okay, there are other considerations, and it is open. Now, the design verification principle, they have not really changed since the first generation, because it's basic physics, I would say, okay? So, for new structure, for existing, it's a little more complicated, but for new structures, so we have the verification at significant damage. Being said that beyond this, of course, we are making sure in the development that we are also covering the near collapse. But it is not a verification to be done by the designer. So we are, as I told you, using, frankly, the post-elastic behavior, so in the plastic domain. Okay, so I will come back to the ductility classes, but the basis of that is to ensure deformation capacity, so in cyclic conditions, and cumulative energy dissipation. Because the interest of that is that when you have cyclic in the plastic range, then you dissipate part of the energy which comes from the earthquake. And of course, this is very interesting in terms of solution and cost. But doing that, of course, we need also, to obtain this result, we need to avoid brittle failures, okay, and formation of unstable mechanisms. Okay? So now for the definition of the action is not for the designer, it is for the national annex or for the deciders, for for the legal documents. Okay, so the first way to, so you have seen the different limit states. Of course, to each limit state, you have given level of seismicity to verify. It's not the same. And you have also the consequences class. And you have this table of return periods, which is proposed. It is a NDP. It's one of the choice which can be made, but it's only a safety choice. Okay. And you can see that for the SD verification of normal buildings, CC2, so these are the buildings that are just close to us, okay? We have this return period of the action, which corresponds to the probability of accidents of 10% over a design service life of 50 years, which is very high, okay? But you should realize that it is a compromise. It is a compromise between safety and cost. So we ask to the designer to make the verification at this level of action. But of course, the code developer has to take care of what happens after. Of course, we do not accept to have collapse, so to have cliff effect just after this value. So this is important. So of course, it is transparent to the designer, but it is, of course, developed in the code. Okay. Originally, we had to each category of importance, we have a coefficient, but it was only related to the CCs, to the consequence classes. Okay. But you can see that we need to have also the action depending on the limit states that we are considering. So in parallel to that, we have this performance factor, which is the same than the importance factor, but it's, let's say, more general. But it is equivalent. And of course, the member can choose either this one or this one. This has been introduced because we have seen that in some countries, they prefer to define the return period than the conference. So people may choose what they want. Of course, both are NDPs. We have introduced another safety choice, which is a seismicity index. In fact, it defined a certain level of seismic action. Okay, and this has consequence in the verification and in the design. Okay, in that, you have part of it which depends only on the seismic action, so which is defined elsewhere. Okay, but you have this seismic index, which is the choice of the member. Of course, the recommended value is 1. But it is not exactly the definition of the seismic zone. It's clearly an index, a seismic action, which is related to the safety which is wanted by the member. So delta is fully in the hands of the members. Okay. Once you have chosen there, then you have the, this is not an NDP, because the NDP is there. So you have different classes. And so the designs are related to these classes. The interest of that is that it is common to every type of structures. So it is relatively simple for the approach. Now people have to choose the delta. Another thing which is new is the definition of the elastic spectrum that we are using for analysis. Before, the shape is the same. So the global shape is the same. We have just added this point, which was not, before it was just a straight line. We have added that. Okay, it's more refined. But the main change is that before the spectrum was fully anchored on the peak ground acceleration. But this is not really, this is a parameter that seismologists like very much, but engineers, in fact, don't need it, because we have no structure with a 0 period. So it does not exist. So we have introduced 2 points, not 1, 2. One on the plateau, so which corresponds to the range of very stiff structures, and another one here, okay, which is at 1 second, and which correspond to flexible structures. So we have 2 anchor points and not 1, and it is better defined for engineers. Okay? Now, another important thing, it's about, I think I'm very long, huh? Oh, yes. New definition of ductility classes. Okay? So here is a recent map for the HAVART in Europe, and you can see, so this is values S alpha. It's a map for the plateau of the spectrum, and you can see, of course, that the high seismicity is concentrated in southern country, Italy, Greece, etc. Okay, middle Europa is, let's say, moderate seismicity, and you have no seismicity or negligible in the northern country. So the idea was to fit the ductility classes that we had to new definitions and new approaches, okay? So we have changed completely. Before we had DCL, DCM, and DCH. The new ones are different, so you can't forget. Okay, they are different. The only one which is similar is DC1. But here there is a main difference, because before DCL was recommended for low seismicity. But it was general and it was not really convenient, because the risk in the structure is not the same. Okay? The criticity of structure is not the same to earthquake. So we had to make a modulation for the limit of use of DC1. This is very new, and if you look at the limits, which are defined with the seismic index, okay, then you can use a lot of structure even in moderate seismicity regions. So not only in low seismicity. So this is advantageous because this is much simpler, because you just make a linear analysis and you use the other Eurocodes. This is the basis. So it's completely different. DC2, the intention is to calibrate it to moderate seismicity. So it is not the same as the previous DCM. And DCH is similar to the previous ductility class, M and H, with the difference that it is simpler. Okay? So, for DC2 and DC3, the principle is to use ductile design. Okay? So, in the plastic range. For this, you know the objective, it is to have ductile modes of deformation. So for those, we locate the plastic zones in the structure, and we eliminate the brittle failure. This is the principle, and this is made for capacity design, but capacity design is only for DC2 and DC3. Yeah? Okay? So I'm just saying that, of course, there are choices which are made, and in a case, they are based on compromises, because we always have to have a compromise between the risk and the cost, and also between force and ductility, between the strength and the ductility. It's not the same. You may have a lower strength, but a higher ductility. So this is the choice that the designer has. Okay, but it's open. Perhaps I'm too long, so I will perhaps stop. I will just say a word about ease of use. So DC2 is simpler than DCM. DC3, so the new one, is in fact intermediate between DCH and DCM, but it is simpler than DCH, because DCH was not so much used, because it was complicated. So we have basically the rules are the same, but they are more detailed and more explained to help the designer. And we have also introduced a new method for defining the partial factors for materials, for instance, for resistance. And this new method, of course, simplifies the way to introduce the partial factors in the national annexes. So there are a lot of simplification, in fact. But of course, on the contrary, we have a lot of additional content in all parts. So on one side, we have simplified and decreased because we have avoid repetition. But on the other side, we have introduced a lot of many things. Okay, but as was mentioned before, ease of use is not directly linked to the volume. Okay. Now we have introduced a lot of flexibility for members. So there are a lot of choices which may be done by members. Huh? First, you don't have to use Eurocode in very low seismicity. Of course, because we consider that Eurocodes are well written by our colleagues, and we don't need to do more. That's all. So you just use the Eurocodes. Now, in low seismicity, there are many openings to introduce simpler rules, at least for certain types of common structures, okay, which has already been done in the last generation by several members. So, of course, this is still possible. We have removed everything which was too linked to local production. Okay, so for instance, for masonry, there are openings such that there may be a complementary document to apply the principle of Eurocode to local production, of course. But you have the minimum of requirements, minimum of strength, etc. Of course, we have to take care of. We have removed a lot of most of the shall. So the code is basically written with should. But we also have increased the number of may. So it's open to alternative method. I think I have to stop. This is what you want to say. Okay.
The presentations are online, and I think we are only missing 2 slides. Thank you very much, Monsieur Bisch, and thank you also for reminding us that the safety level is a choice and hopefully an informed one. So I know our audience in the room is a little camera shy. If you have any questions, be quick and raise your hands. Okay, nobody can continue.
Carmen, thank you. Let me say that I'm appreciate for the last session, also the other ones, so thank you for that. Before we start the Q&A for our last session, I would like to express my gratitude also for the online attendees who raised questions and comments. We received so much. Thank you for that, and it's impressive to see how many people we have online. It's the new technology, the same as we use in Eurocode, we can see here. It's tremendous. Thank you for that. Now let's start with some questions for you, especially for Stefan. There's a question we discussed a little bit earlier. So why are material properties and values given and included, for example, in Eurocode 2 and not in Eurocode 5? Can you explain something or say something about that?
Yes, I think so. The reason is because Hans was not able to rely on a construction product which is given in a harmonized European technical specification, concrete. And that's why you give for certain classes the design values or the characteristic values in Eurocode 2. In Eurocode 5, we are relying on, for example, EN 14080, which is a harmonized construction product standard for glulam, coming with the CE mark, coming with the declaration of performance. That's why we are only mentioning in Annex M which properties we need for design, but we don't give the property. The properties are given by the construction product harmonized specifications. So, and I think it's a little bit the same with soil, of course. Yeah? You do a lot of testing,
yeah.
and you get your own characteristic values from tests. Yeah. Soil is not a construction product. Of course, it's there where it is. Yeah. I think that's the main reason.
Yeah. Okay, thank you. So, are there some lessons for the other Eurocodes which they can learn from EC5? Or is it so specific that?
No, well, if you are looking at the harmonization with the construction product regulation and the harmonized European technical specifications for construction products, I think in many cases we have the same situation, like in steel, for example, and in other areas. I know that there were some problems with reinforcement steel, for example, because and that's also the case for the Eurocode 5, we sometimes need properties for the design which are not given by a declaration of performance according to a harmonized specification, whether it's a standard or an ETA. And that's why we did this exercise, and we did this exercise with all Eurocodes based on the ad hoc group interface, that we sampled all the strength and stiffness properties and sometimes others like density, which we need for fire design very often, so that we are able now to provide a list with all the properties we need given by the declaration of performances from the different construction products. And I think this is a big step for harmonization and for ease of use. At the final end, it's always the same target. We have to verify that what is designed is built. And this, many of you are in practice, you know, this is really a difficulty very often on the building side to decide that it's an S700 and not an S235, which is delivered. And that's what we have to verify. And therefore, we need the whole system. And therefore, we provide now all this information to the Commission and to the technical committees dealing with the construction products harmonization and standardization.
Okay, thank you. There is one short question, maybe a short answer is possible. It's about the boundaries, or the question is, does Eurocode 5 also handle with connections between timber and other materials, for example, masonry and concrete?
Then you have two parts. Then you have normally a steel plate or something in between, and then you have a connection to the timber part, of course, and then you have a connection to the masonry, which you have to handle according to the rules for connections to masonry. Or you have a steel timber connection, and then on the steel side you are using the design rules for steel connections. On the timber side you are using the design rules for the timber connection.
Yeah, thank you.
Every building is hybrid, and you have to use the Eurocodes also in a hybrid way, of course.
Yeah, great. Thank you. Adrian, there are two questions for you. One is soil degradation due to cyclic loading considered in design of slab foundations, including in Eurocode 7?
We do, of course, because soil degradation is existing. We got a part on cyclic materials, cyclic testing, and cyclic properties of materials. And degradation is one of the things we look at. Yeah.
Yeah. Okay.
And we are using it.
Yeah,
of course. Yeah, of course. Of course. The second question was, you mentioned numerical methods and probabilistic design. So it's quite good to, I think it's quite good to have these methods now. Can you give some insights when we use numerical methods or models, and when they are preferred over analytical methods?
Yeah, it's of course because then you look at the reliability of models, and in the analytic ones, there's a lot of experience behind it. Sometimes you can in your finite element model, or sometimes it's not the fabrication phase may not be introduced in your complete models, because then it gets very big. So I cannot say which one is better. Sometimes a very simple one is analyzing it, the thing you need, and because you have experience with it, you also experience with the parameters going in. Whereas, but in the end, numerical methods have the advantage that they check various failure mechanisms. In analytical, you have a failure mechanism for this model, for this failure mechanism, that for the other, and that for the third. And it's all done in a finite element model. So that's a huge advantage.
Yeah. It's just one new tool in your toolbox, yeah?
Yeah, exactly. Yeah.
Okay.
But then probabilistic is then the next step, where you go into risks and combining risks and optimizing your structure. So that's really, I think that's especially for geotechnics a very good tool.
Yeah, great to see. One question only for EC8 is the new EC8 more specific on design with base isolation?
There was already in part 1 a full chapter on base isolation. So this one is not changed a lot. In fact, it's let's say our evolution, but it's quite the same. But the difference is now we have new chapters for other types of equipment, of devices, for use of dampers, of use of many types of systems, not only isolators, which may be used for buildings, bridges, tanks, etc. So you have, let's say, the principles are given in part 1 in a specific chapter which covers isolator, but the other types of equipment. Okay, and you have a more detailed application in part 1, 2, so for buildings and bridges, for the application, for the detail, in fact, of design, for these different types of structure. So the principle is always the same. You have the main principle and the main procedure defined in part 1.1, and then you can use it with applications, of course, in the other parts. But so at the end, isolators is the same, but there are a lot of new developments.
Okay, thank you. Carmen, please go ahead.
Thank you. This answer closes this question and answer panel. Thank you all.
Thank you very much to you as well.
This conference is drawing to a close, but we have some minutes to wrap up. So I would ask the chair and vice chair of CENTEC 250 to the stage once more.
Okay.
Thank you.
Thank you.
They're already on. Would you like a glass of water? I'm good. Okay. It's been an intensive and instructive day. I think we've all learned a lot and taking home some points to research further. To conclude, I would just like to gauge your thoughts on the future of the Eurocodes and today's conference. Steve, I will maybe start with you.
Sure.
Than 10 years of work on the second generation Eurocodes lie behind you, and another couple still ahead of you. All in all, is it worth the effort?
Yeah.
And will the second generation of the Eurocodes be as successful as the first one?
Well, do you know, I think, isn't there the expression that beauty is in the eye of the beholder? So I think whether it is a success or not is really not for me to judge. We will have two indicators of success fundamentally. One indicator will be the voting process and the extent to which we've achieved consensus. But in many ways, the most important indicator will be the reaction that we get from practitioners. It'll be about whether we have improved the ease of use and whether the additional content that we have added into the standards helps people to tackle the new situations that we need to tackle, the new imperatives that we have, particularly in relation to sustainability. And so actually, I think time will tell. Time will tell. But I am immensely proud of all of the work that's been done. I'm very proud of the approach that we've taken. And I think when we came into this project, there was no playbook for how you do a standardization program of this scale and this importance. And over the last 10 years, we've learned an enormous amount about how to do that. And I do hope that part of the legacy from this work will not just be a better set of Eurocodes, but actually some really healthy learning amongst the standardization community of how to do large coordinated programs, because I think we've really, so we've learned a lot, and I think there's a lot for us to share from that. And I have a couple of other reflections, but perhaps you'll come back to me and I can add those later.
Well, I think what you said couldn't be more true, and maybe it's also time for a big round of applause for all experts who have contributed to this huge project.
Absolutely.
So, all of you.
Might I also just add a couple of quick points? So Gerhard and I were speaking earlier. I think it was in the third session when there were two questions that really stood out for me. There was one question that essentially was challenging us to say, have we simplified enough? And there was another question which said, this simplification you've done, does that mean that our designs are now going to be less economic? They were two questions pulling in completely different directions. You know? And I think one of the challenges for us so often has been to try to find the sweet spot, the balanced position. You know, that's part of the challenge for us. I think that the work we did at the start of this program to define the criteria that we should use to assess ease of use and other things was really important. But again, I hope that stemming from this conference, stemming from other things that happen over the next few years, that when people receive the new Eurocodes and look at the new Eurocodes, they will understand that we have worked really hard to try and land in the right place in relation to that balance. And I did want to echo your thank you. I mean, a thank you to the thousands of people who have worked on the evolution of the Eurocodes. It's been a quite enormous effort with probably around 1,500 experts operating at a European level and probably 15,000 operating at a national level. It's been a huge endeavor. And I think everyone is just immensely grateful to everyone who's engaged in that. But also, it's so exciting to come to an event like this. I realized this morning that it's the first time I've stood up and spoken to an actual audience for years, because mostly it's been, recently it's down the lens of a camera. But actually to organize a hybrid event in this way, which means that we can engage in the room, which is fantastic, but to have 1,500 people watching this online from 60 countries, I think is just a testament both to your meticulous organization, but also to the importance and level of interest in the work. And so I thank all those people who have joined online. I hope it's been a successful experience for them too, and that they've had a useful and productive day as well.
I can just join in that. Thank you, Steve. Mr. Breitschaft, what is for you the most important message we should take home from today's conference?
Yeah, I think the most points Steve already mentioned. Today we heard about the reduction of number of pages, and it was very often said and it was discussed, and I think that's one of the most important things we learned today. At the end, we will not have a reduction of pages for sure, because we added so much more content. Yeah, and I think that's the most important point. It is our task to reflect the state of the art, and we have a lot of new technical innovations and in materials and methods everywhere, and it was necessary to put these new innovations in our Eurocode. So there was no way to look only at reduction of pages. So I think I agree fully with Stefan and others. If we take on board new materials, new methods, we have to have more pages. But on the other side, we looked also to ease of use, and I think we did a lot of work on this. We reduced some chapters, we reduced textbook-like descriptions, and I think it's a good effort and good result. And additionally to the new materials and methods, we had to look to sustainability and to the impacts of climate change. It's a new task. It's coming from the society, from the politics, and it's also a reason that we produce a little more pages. So at the end, I think today we get a good overview that we all looked at this new issues, and I hope in a few years we finalize this really huge project. And I have also to thank to all our colleagues who managed this tremendous amount of work at the administration level and at the technical level. It was really a very, very big task, and it is still a big task. You see, we have some issues open. We have to discuss, we have to find consensus. And so I think we will succeed, but we are not finalized today. But I'm very hopeful that we will finalizing the whole process in a few years.
Yes. So yes, yeah. I see that.
Yes, it does feel sometimes a little bit like climbing a mountain, and I'm not sure if I think we're past the South Col. We're maybe not quite yet at the South Summit, but we definitely still have a little way to climb to get to the summit of our mountain, and we have a couple of years of work left to go. But I did think that there were a couple of points that would be helpful just to share. One is that I hope one of the things that's come across today is that we have a coordinated and managed program. That I think that when you're drafting a standard, you tend to be very focused on a particular clause, a few pages, some particular paragraphs of a document. But of course, the user's experience is to use a suite of standards. And when you use a suite of standards, what really matters is the consistency, the ease of navigation. And that's why I hope what's come across is that we have worked very, very hard to think about the experience of using the Eurocodes from that user perspective and think about how we can improve consistency, improve navigation to make that experience better. And the extent to which we've achieved it, of course it won't be perfect, but hopefully people will have taken away some reassurance that there's been a very conscientious effort in that direction. And I think as just a final remark from me, I guess in a way it's a reflection of the scale of the work that we've been doing, that we've had a very busy day today, but in some areas we've barely scratched the surface. And I think that today's been a brilliant day, a really brilliant day. But we do have plans as TC250 to continue to work to communicate what's happening with the evolution of the Eurocodes. I mentioned earlier the partnership that we have with the Joint Research Centre of the European Commission working on communications. We have some videos that we've produced that again provide some general information, but there's also a real commitment that I hope again you've heard today to look to share more of the technical background, more of the technical details in due course as the standards are finalized. So I think for that it's a case of watch this space, but we're working hard to bring more communication around the evolution because we see that as being actually an important part of our responsibilities beyond the production of the documents themselves.
And we wish you all the best for it, and thank you for your commitment. Thank you for these inspiring last words.
Some last words.
Yeah.
Very last words. I want to thank all the speakers. It was, yeah, you managed this session. We also did something behind, we organized something, but it was really important to have your contribution. You made the technical work, you made the framework work, so thank you very much for your speeches today, but also for your work you have done in the last decades. And I also want to thank our audience. I think we make you a little bit tired. And of course, I also want to thank my staff, Carmen and her team. It was, you can imagine, we had to do something in the background, and everything worked well, and thank you very much for that.
You've already mentioned all my speaking points for the final part. So thank you to our partners also. We have heard the Joint Research Centre several times. So also our sponsors. I've been named, I would like to name two more colleagues at least, Doris Kirchner and Christine Settler, and of course all of you others in the events team. And yes, thank you for your attendance, your active participation, and also your patience with our rigorous timekeeping. It was great to learn about the advancement and innovations the next generation Eurocodes will bring. And I'm sure we all look forward to seeing this success story continued in the future. Thank you all for joining us today. A good journey home for all who are here with us in the room, and a good evening or morning or day or night to you all. Thank you.